Hello and welcome to BrowserStack's monthly webinar. We are getting started now. Good morning, good afternoon, good evening to you from whichever part of the world you're joining us from. I hope you're staying healthy and safe. My name is Jed Leve, and I do product marketing here at BrowserStack. And I'll be your host for today's webinar with Roy DeClain, optimizing test automation for speed, robustness, and increased coverage. And I have Roy here with me, so let's give Roy a hello. Let's start with a few housekeeping items. Runtime for today's webinar is 60 minutes. We'll have 15 at the end for Q&A. We encourage you to ask questions as and when they come up using the Q&A button on the Zoom interface. I'll be going through your live questions for Roy, and we'll cover as many at the end. This webinar is being recorded, and we'll be sharing that with you soon after. With that out of the way, I just want to spend a few minutes introducing you to BrowserStack, a little bit about our history. BrowserStack actually just turned 10. We'd launched in 2011. Our first product was built to help developers test their websites on IE. It took 6 months to get to 1,000 customers. And since then, it's been a rocket ship of a journey. Our co-founders, Nakul and Ritesh, literally built the first version of BrowserStack out of a coffee shop. They built it to solve a problem that they were facing themselves as developers. They were building a website for a project. It took a few days to develop it, but when it came time to test it and make sure it worked on IE, they faced a lot of troubles given they were using a Mac. They realized this is a problem that developers and testers all around the world are facing, and that became the inspiration for building the first version of BrowserStack. 10 years later, we have scaled our infrastructure to launch new product lines, and most recently secured Series B funding. Today, we have offices in San Francisco, Dublin, Mumbai, and New York. We're 800 employees strong from all around the world. We're proud to serve over 50,000 customers across industries, including leaders of every industry. BrowserStack is also used by many open source projects, which we sponsor, including jQuery, Angular, Ember, and many more. If you're working on an open source project, just give us a shout and we'll set you up with the sponsorship. Here's a scale at which BrowserStack operates. We have over 4 million registered users, process over 72 billion Selenium commands every year through our web automation product, which I'll talk about momentarily. And we've got over 15 data centers, global data centers covering 135 customers from 135 countries. Some of the world's largest cloud providers rely on our platform. Amazon, Google, Oracle, and Microsoft all use BrowserStack to test their web and mobile applications. Our customers use these products. We've grouped them into 3 different categories: web testing, mobile app testing, and free tools. Under web testing, we have 3 main products: Live, Automate, and Percy. Live is our cross-browser testing tool where you can interactively test your website on 3,000 different browser and mobile device combinations. All your mobile tests run on real devices, not emulators or simulators. Automate is our web automation platform. Our customers use Automate to speed up their test suites through parallel testing on our desktop and mobile cloud. Automate is framework agnostic. It works out of the box with Selenium, Cypress, Puppeteer, Playwright, and many other JS testing frameworks. Percy is our visual testing and review product. With Percy, you can compare what your website looks like against the baseline design on different browsers your customers use. Next up, we have mobile app testing, which our AppLive is the counterpart of Live. You can use AppLive for manual testing of native and hybrid mobile apps. You can use App Automate to run mobile app automation on real iOS and Android devices using Appium, Espresso, and XUI test. Lastly, we have these set of free tools. Screenshots allows you to generate screenshots of your websites across different browsers and devices. You can use our responsive tool to quickly see how your website renders on different iOS and Android devices. And our latest addition to our free tool, SpeedLab, helps you test the performance of your website on different browsers and devices and gives you a score on how fast or slow website is, along with a few insightful benchmarks. As part of today's webinar, we are offering all attendees a BrowserStack pack, which gives you free unlimited access to all our products for 1 month. You can claim BrowserStack pack using the link shared in the chat. Quick and final announcement, our field team here at BrowserStack is looking to bring you topics most relevant to you. You'll see a 2-question feedback pop up on your screen. Please take a moment to share your feedback with us. Thank you. So without further ado, let's talk about Optimizing Test Automation with Roy. It's my pleasure to welcome and introduce Roy de Klein. Roy is a test automation consultant from the Netherlands. He brings a wealth of 12 years of experience helping organizations automating their testing, from front-end automation to performance testing. Every year he trains over 25 organizations, working very closely with 500 test automation engineers. In his spare time, Roy enjoys passing on his knowledge to children, teaching them coding, electronics, and 3D printing. Now, over to you, Roy. Roy, I think you are on mute.
Thank you. I will share my screen.
Awesome.
Yeah, thanks for the nice introduction, and thanks again for having me. Hello and welcome to this webinar. It's great to see so many people from all over the world. And welcome to this webinar about optimizing test automation for speed, robustness, and increased coverage. Let's give me a few words to introduce myself. Like Jay said, my name is Roy de Klein. I'm coming from the Netherlands, a town called Utrecht. My situation is that I'm married. I have two kids. One is 8 months old and the other one is 8 years old. And for my living, I am a freelance test automation consultant. And next to that, I like to train and coach people. I have about 12 years experience. And in my spare time, I do coding with kids. I like to travel. Of course, now it's a little bit difficult with the pandemic, but I like to travel and then taste local cuisine and wines as well. But let's get straight to the content and much more interesting stuff. So today I like to cover at least 3 topics. One is about waiting strategies. The second topic is about integrating BrowserStack. The third topic is about test reporting. And in the end, we will have a 15-minute Q&A session. So let's get started with the first topic about waiting strategies. If you look at the test automation tools which are out there, waiting is always a challenge when you make an automated test script. If you don't implement a correct waiting strategy, then people will lose trust. You will end up with some unstable test, and tests are waiting probably too long or too short, which will cause a failure, of course. And your test might work on your local machine, but might not work on the build machine, or might not work if you integrate your testing with BrowserStack or other cloud providers, because it will introduce a little latency to your test execution. And if you implement the correct waiting strategy, you will optimize the feedback cycle. Your test will just wait long enough, not too short, not too long, just long enough. And in the end, you will increase confidence. People in your team, in your organization, will trust your test. If a test every now and then fails, then people lose trust in your test. But if a test will fail with a very good reason, not just a time-related thing, then people will trust your automated test. So if you look at some waiting strategies, there are about 4 waiting strategies. The first is having no waits. Then you can have hard-coded waits, which is a kind of static waiting strategy. Then you have the implicit waits, which is a dynamic waiting strategy. And then you have the explicit waiting strategy. I will cover each of them. Not having waits is kind of tricky. It might work in some cases, but in most cases it doesn't work. It doesn't give you robust test scripts. If it works, you are lucky, but mostly it doesn't work. So let's skip to the next one. You can have hard-coded waits. You are probably familiar with the Java code thread.sleep. Almost every programming language has its own kind of thread.sleep. And this statement will hold the execution of your program. So that's a kind of tricky, basically, because you don't know if you wait just long enough. Waiting too short can result in a failed test case, and waiting too long will slow down your feedback cycle. And those two things you don't want to happen. So what you can do is to implement an implicit wait. That's already an improvement because the implicit wait is a dynamic wait, and the downside, the drawback, is that it applies for every element lookup. So it probably will slow down your test execution a bit. And in a lot of cases, you like to be a little bit more specific in how and for what kind of elements or status you like to wait. And imagine if you implement an implicit wait, what will happen if an element, if you like to check if an element does not exist. If you implement an implicit wait, it will throw you an exception, a no such element exception, and that is not really helpful for your test automation. This is how the Selenium WebDriver implicit wait looks like. It takes two arguments, and the first argument is a number, and the second argument is the time unit. So this will wait at maximum 30 seconds for every element lookup. And this is probably not what you want. Because what I mentioned, if you like to check if an element does not exist, well, this doesn't really work, those examples. If you just try to find the element and check if it's not null, for an element that does not exist, then it will wait your implicitly wait timeout, and eventually it will throw you an exception, the no such element exception. The second case is a little bit better. Here we try to select a list of elements and then check the size. Also, this one will wait the implicitly wait timeout, but in the end, it doesn't throw you an exception because this will get you a list of elements, and this list is empty, 0. So it will delay your test, but it doesn't throw you an exception. And the third one that doesn't also work really well. Here we try to find a non-existing element and check the is displayed. So what it does, it will pull your DOM, it will pull your HTML for about the implicitly wait timeout, and then it will determine that it cannot find your element, and then it will throw you an exception. So those cases don't really work that well, and you can improve that by implementing the explicit wait. The explicit wait is a conditional wait. So it waits till a certain condition is met. And this kind of waiting mechanism will just wait long enough, not too long and not too short. So if you implement it properly, it will always work. But the challenge might be that you need to find some maintainable implementation. Otherwise, it will be kind of hard to implement it in your test automation framework. This is an example of how it can look like. So you define the WebDriver wait, and here in between the until, you define some condition. In this case, we are waiting for the visibility of this element, an element with the class name alert success. I prepared some demo of the things that can go wrong, and I like to show you the demo, and then we will cover 3 ways to improve it. So this is a class file with 4 test cases, and those 4 test cases show you a very basic test. What we will test is this website. We will enter 3 values and we click on save. Once we do that, a loading a message will appear after some time, and that time is kind of randomized. So that's also the tricky part. So let's see what happens. The first one is executed without waiting mechanism, without waiting strategy. So it's really fast. It also entered some value, but they all failed, of course, because it couldn't find the alert message. So the second strategy is the same script, but now we implemented a hard-coded wait, a thread.sleep 5 seconds. And I execute it 5 times to show you the effect. So to open a website, it will wait 5 seconds, of course. And then it will start a new, reload the web page and enter the values again. And you see that the time is kind of randomized. Now it's much faster. And now it is a bit slower. Like how a real website behaves. So now we have a little bit more success. 1 passed out of 5. It's a little bit better, but not really what we want. Of course, we want a 100% success rate. So we try to implement some dynamic wait. So let's start with the implicitly wait and see if this will resolve our problem. Now, you probably noticed by the speed of the test execution that it doesn't really help, because the result element is already in the HTML. It's only not visible. So the implicitly waits till the element is in your HTML, and then it performs some check. The isDisplay check fails because it's in the HTML, but not visible yet. So this is not really what we want in this case. So the last example, in this example, I removed the implicitly wait and I introduced the WebDriver wait. So the explicit wait with a certain condition. So this condition waits till the element is visible. Let's see if this works. It's now entering the wait condition, and it polls the HTML for about 40 seconds. And if it can find the element earlier, like this, probably almost there, like this green box, then it will continue. This green box, yes. And also this test is executed 5 times to show you how it works with different timings. Like this is a bit faster. Yeah, 1 left, I guess. Yeah. So it already takes a bit longer to execute our test cases, because the waiting in this case really works. And you can also see it by the result here, like 5 test cases and all 5 passed. So it's the exact same test case, but the waiting condition is different. So by showing you this demo, I'd like to visualize that the explicit wait, the WebDriver wait, is one of the best waiting mechanisms. But now we have only one problem, and that is how to implement it. And there are different ways to implement the explicit wait. And I will discuss, or I will show you 3 different ways. And you can decide on your own which is the best. And they're all equally fine, but some are a little bit easier to maintain in the end. So number 1, that's what I quite often see in projects, is that they implement a kind of helper class, and they can just call this helper class with helper methods to do the waiting for you. That's one way to do it. Number 2 is implement a listener. I will explain that briefly to you in the next coming minutes. And number 3 is custom WebDriver implementation. And you can basically customize the existing WebDriver implementation and enrich the functionality with waiting methods. So I will show each one of you to you. So the helper class that can look like this. So we have a wait helper class with a constructor, and this constructor creates a new instance of WebDriver wait. And in this case, we have wait and click, and we have wait for visibility off. Now, wait and click will just wait till the element is clickable, and wait for visibility off will wait till some element is visible, and then it will return that element. That is basically what this simple helper class does. Of course, you can extend it with much more helper methods, but that doesn't really fit on this slide, so I didn't do that. So this is an example on how you can use this helper class. The exact same script, only a few modifications. Like in this line, we make a new instance of wait helper, and we provide our current driver session. And in this line, it's highlighted here, we call wait, because that's the name of the field. And we call this wait method, wait for visibility off. And it actually waits till this element is visible, and then it retrieves the text. And that is stored in this alert text. So that actually works, that's fine. But we can improve it maybe a little bit by implement a static helper class. And that can look like this. So again, we have a class with some static methods. And we have, again, wait and click. And this wait and click does the instantiation of WebDriver wait for you. And it also wait and click, of course. And we have wait for visibility off, and that does the same. It creates a new instance of WebDriver wait, and then it executes the condition. The drawback of this is that we need to pass the current driver and also probably a timeout. That's one of the nicest things to supply. And you can implement it like this. If you remember, we had to instantiate a new class in the setup in the previous case. That's now removed because we can just call the static helper class with the static method inside. And then we pass the driver, the element we like to wait for, and also the max timeout. So this works as well. But I think there is a better way to implement it. Oh, let's do the demo first. That was the wait helper. I make it 3 because then we are a little bit faster. So this is the first case. I implemented the wait helper class, and it works. It waits now. It waits maximum 40 seconds. 25 seconds, also fine. And then after it will perform the next test. So that's quite nice, eh? 3 out of 3 passed, so that's really what you want. But the implementation is a little bit, it can be done in a much nicer way. Let's put it like that. Because we need to instantiate the wait helper class, and here we call this wait field, and then we can call the wait for visibility off method. So it is already improved by looking at the static code. The setup is a little bit cleaner, so to say. And here on line 39, we just call the static wait helper with this static class, and then we pass the current driver element and the max timeout. So that also works. does the same, only the coding is a little bit different. So let's have a look at the next implementation. That is called a listener implementation. So in programming, a listener can listen to certain events. And WebDriver itself comes with a listener. In WebDriver, you have the WebDriver event listener. That's quite nice. And in most test frameworks, you also have listeners. But we will take a look at that in the next minute. But first, we take a look at the WebDriver event listener. So we can implement WebDriver event listener, and then we can override or listen to certain events, like the before and after find by, or we can listen to the click functions, or we can listen to the get text. To those actions and many more, I guess 15 in total, we can listen. But if we implement from WebDriver event listener, then we need to override all 15 methods. And that's in most cases not really what we want, because we like to override in most cases only 1 or 2 of those events. And by doing that, we can extend our listener class from abstract WebDriver event listener. And then we can override only specific methods. So there is no need to override them all. So that sounds maybe a little bit abstract. So I have some example. I have my WebDriver wait listener, which I created. It extends from abstract WebDriver event listener. And here you see those 2 methods, before click on and before get text. And in those 2 methods, I do the waiting. So before I click on an element, I like to wait that this element is clickable. And then I click on it. And before retrieving text from an element, I like to ensure that this element is visible. Right? These are the 2 conditions that apply for my project. And further, you can see a constructor. This is called a constructor. And there I instantiate a new WebDriver wait with the driver session. So how you can use this listener is as follow. So this is a pretty standard setup method. I create a new Chrome driver instance, but after that I register the WebDriver wait listener. So we can create first a new instance of event firing WebDriver. That is the default class of Selenium WebDriver in Java. And on this instance, we can register our own listener or listeners. And you can have multiple listeners if you want. So that's quite handy, because now you don't have to change your test cases, because it will listen to the events. And if certain events will happen in the browser, then the script will wait automatically. So let's take a look with the listener. So if you look at the script itself, I will execute it only 3 times, because then we are a bit faster. If you look at the script itself, you don't see any waiting condition or whatsoever, because, I will zoom in a bit, because that is done in the WebDriver wait listener. So the important part of this is the WebDriver wait listener extends from the abstract WebDriver event listener, and this class contains only 2 methods, like the before click on and the before get text. And this holds the wait condition. Before click on waits till the element is clickable or not, and the before get text waits till the element which contains the text is visible. So let's run this test. And see what happens. It waits. And in this case, it takes a little bit longer. Yeah, it's totally randomized, so I don't have impact on that. It's much faster now. And a little bit slower again, yeah. But the end goal is that we should end up with 100% pass rate. And as you can see, the result of those test cases is green, and they contain an assert, so they will be red if it's not good. But it's 100% pass rate, and this is exactly what we want. And we didn't really change our test implementation. So everybody can easily implement this in an existing code base. That's not so, it's not really hard. So let's take a look at the third implementation, which is also quite nice to see, I think. That is a custom WebDriver implementation. So you know this WebDriver class, and we can easily create our custom WebDriver class by implementing some interfaces. I think, yeah, it will highlight, nice. It will implement WebDriver, and in this case, JavaScript executor. So all the methods in WebDriver interface and JavaScript executor needs to be implemented in my own class. Well, that's not what you see in this example, because that doesn't fit on the slide. And that is also not so important. The important part is this, that I overwrite a constructor with a normal driver. And in the body of the constructor, I can better show it like this, we have the default timeout and the default sleep in milliseconds. And this will create a new WebDriver wait instance. And then we can do certain things with it. Like we can extend the behavior and the methods of a WebDriver. And now we have a wait for visibility off in our driver object. I will show it to you how that looks like. Yeah, here. So again, this is the same class, but now we have a custom WebDriver in this line. And this custom WebDriver can receive a Chrome driver or a RemoteWebDriver or a Firefox driver, any driver. And the only change is in the test script. You see that the field or the field has the name driver, and all the find by actions are also done on this driver instance, but also the wait for visibility off is done on this WebDriver instance. So I will show it to you how that exactly works in some code. Yeah, here's code with custom WebDriver. And I will open this also. So what you can see is that this custom WebDriver implements some interfaces, and by implementing those interfaces, you will need to implement a lot of methods as well, those methods. But that's not really what I changed. I changed, yeah, this one. The wait for visibility off. So I added that to my custom WebDriver, and now I can do this. I can type here driver dot wait for visibility off. And this method will do all the waiting for me. And of course, I added only one now, but in the code you will be able to download afterwards. There will be much more waiting conditions. And I like to show to you that also this test case works. I changed it to 3 to save some time. So again, the exact same test case. So first Takes a little bit longer now. And you see the script waits till the condition is met, and then it will continue. Like 3 test cases run, and all 3 passed. So that's also quite nice. We didn't change too many things in our test script, only we added this line of code. So it really depends on your implementation, on your framework, which waiting strategy is correct for you, and which implementation works best. I personally very much like the listener one, because then you can just take some existing test cases from your project or some organization and improve them by adding this listener. So that's really worked well in my previous project. So let's dive into the second topic of today. That is how to integrate BrowserStack on existing project or new project. That doesn't really matter. There are some steps involved. First, we need to define the browsers we like to test. And we can define those browsers or browser operating system combinations in a JSON format file. I made some utility that can actually read this JSON file, and then it will give you a set of capabilities. A set of capabilities that match the BrowserStack standard. And then we can actually create a remote WebDriver, and the remote WebDriver understands the desired capabilities and will set up some session if you're authenticated and so on. And in the end, that's a nice feature we can leverage, is that we can update our test status in BrowserStack dashboard. And we'll show that to you in a minute. And number 4 is that we can easily, by utilizing this feature, implement parallel test execution. Well, we start with number 1. So we need to decide on which browsers we like to test in, and we can gather those information from our product owner or product manager, or if it's an existing application, we can take a look at Google Analytics, for example, or some other analytics tool. And then we can try to define those things in a JSON-like file. And this contains 2 things: common capabilities, that are capabilities that apply for all browser sessions we will start. And it defines some environment capabilities, and that defines the different environments we like to test in. Now, in this case, you only see 2, like Windows with Chrome, and we see OS X with, also with Chrome. And now the utility I wrote can easily read this file and select the correct environment. And that is actually what is happening here. We can select the environment based on index number, and the default one is 0. It's a 0-based index. And then we pass this number through my utility, and this utility will extract the relevant information, and it will create all the desired capabilities for you. And the second line, well, it's not highlighted. The second line will create the remote WebDriver session with the BrowserStack URL, and it will pass then the capabilities towards it. And then you can start testing. So let me provide you a demo. So we have the, if you're familiar with Java, we have the normal setup method, and we are using here testng. That's one of the most popular test frameworks. And we pass one parameter. And this is the environment capability ID. And next to this setup class, we have the BrowserStack JSON file. And this defines the capabilities, like the common capabilities, and some environment-specific capabilities. And we use a zero-based index, so the test will run in Windows on Google Chrome. Yeah. This generate capabilities method will return you all the necessary capabilities in the BrowserStack format. And then we set up some session and we can run our test. That is actually the only thing you need to do if you like to integrate BrowserStack. I can show that quickly to you with a past test, this one. For this demo, I use a different application, not this simple form, but I use this application, stackdemo.com, bstackdemo.com. It's the BrowserStack test application. It's a web shop. You can buy some phones and you can sign in. And the test I will perform is the sign in test, and I will sign in with a logged account. So that is what you're going to see. And in the meantime, I will open up BrowserStack dashboard as well. And this is the BrowserStack dashboard. That is what you see if you open it for the first time. And let me quickly check. Oh yeah, that is true. That's the tricky part of live demos, but minus p single. I think this will work as well. Yeah, this will run a lot more tests. We won't watch them all, but just a few. You see, this is BrowserStack dashboard, and the moment you start a new test run, it will give you a new entry here, and you can click on it. And here you can see all the test cases that are executed on the BrowserStack cloud. And this is just doing one test by one. You see the first test passed. You can click on it and you see all the commands that are being executed. And then it goes to the next. And then, of course, it will loop through all your tests. But I will stop that now, otherwise it takes too long. So that's quite easy to integrate BrowserStack, luckily. Yeah, indeed. But that is just a basic integration. You can do a lot of more things with BrowserStack. And one of the things is that we can update the status of our test cases in BrowserStack dashboard. Because what you just saw is BrowserStack dashboard that will basically list all your test cases and test commands. But you can also update the status of your test case, if the assert passed or failed. So I wrote some code to update the status. If you see here in the first line, it will extend from test listener adapter. That is a listener of the test-ng framework, and that will listen to certain test events. And you see two events here, on test success and the on test failure. And if one of those two actions occur, then this code will be executed. And so I override on test success and on test failure, and then the mark test status will be executed, and that will actually update the test status in BrowserStack dashboard. And I guess we can also see that now. If I go back to BrowserStack dashboard, I click on here. Yeah, you see here this test passed and this test also passed, and this test timed out for, I killed it. Yeah, that's why. If I look at the previous run, then you see also the passed status. But in this case, you see also a failed status and some reason of the failure. So that's quite handy. And you can easily share this link to this test run with your team members, and they can click on the failed test, for example, and see the exact failure with screenshots. So that's quite nice. This one. Oh, skip that. Yes. So if you like to run our test set, which probably contains multiple tests in parallel, then we need to do only two things, basically. Actually 3 things. The first thing is that you need to ensure that your tests are not dependent on each other, because that will result in some conflicts if you run tests in parallel. So if you make sure that your tests don't depend on each other, then you can do 2 things. The first thing is you can implement test-ng.xml, and this will basically define the test suite you like to run. And in this case, I listed the test classes I like to execute, and with some environment capability ID, so 0 and 4. So 0, it means it will run my test on Windows in Chrome, and 4 was, I guess, here, Android, to run on an actual phone in the BrowserStack cloud. And the second thing you need to do is update your, if you write your code in Java, you need to update your pom.xml, and then you can define that the test need to run with a specific listener. And this is the BrowserStack test status listener. And that will update the test status in BrowserStack dashboard. And the second thing you need to do is define in which way you like to run the test in parallel. Is based on classes, based on methods or test, and in how many threads. So I set it to 5. So 5 tests can be run in once. And the last thing that is this line is which XML file this script should execute. So let's do a quick demo. And then you can see what actually happens if you run this suite in parallel. Yeah, so it started a new session, and hopefully, yeah, you see it happening. 2 tests are being executed now in once. And that will continue, of course. So that's really to improve your test feedback cycle. This can really speed up your test execution. So the last topic I like to touch on is test reporting, because I've seen a lot of frameworks, and the thing people don't really like that much is reporting, because a test does pretty much a lot of things. And you don't see that in the reporting. Sometimes you get a simple graph saying pass or failed, or sometimes you get a dotted output with a lot of dots, and sometimes some crosses. But what we can implement, and that is pretty much available in all programming languages, is a reporting framework called Allure. And that gives you some insights. It gives you pretty clear insights of the steps are being taken, of the duration of certain tests. Yeah, of course, the passed and failed status, and it can give you the input for optimization of your test set. And you can see, for example, if you have some long running tests, and those long running tests you can start to improve. Probably change the weighting strategy, or break it up in smaller test cases, or other things. So I like to show you an implementation of Allure reporting, and that gives you some really nice graphs. And this is the dashboard graph. Here we have a trend line, what the status was over time, and I like to show you some implementation. If you like to implement this in your Java-based project, then you need to add a Maven dependency. And you need to add a build plugin to your pom.xml file. This Maven dependency will basically generate all the raw test result files. And this build plugin will generate the HTML report for you. The next thing you need to do is add an allure.properties file. And this contains the path to your results. If you use Maven or Gradle, those paths are a little bit different. And in the end, if you have run all your test cases, you need to generate a report. And that you can do with this Maven command, Maven Allure report. And then the results are put in this directory, target site, Allure, and then the index.html. That will show you the report. So I prepared some reports and I'd like to show it to you. Yeah. Open. Oh. Was my other screen. So this is the basic dashboard of a single test run. You can click on it and see the individual test statuses. So that's quite nice. And in this case, there was a failure. We also have a screenshot. So you can click on it and we see the state of the application at that time. So that's quite nice. The next thing this reporting framework provides is some graphs. So you have this kind of graphs, of course, with the past failed statuses, but also I like this one very much, is the duration. So you can see in one overview if you have a lot of long running tests, and those long running tests you can try to improve. In this case, this test took between 11 and 12 seconds. Yeah, that's not so long, but if you have like tests that take like 1 minute or 5 minutes, those tests you can try to improve. You can also generate a trend line. No, first this one. We can add more detail to the report because normally you can only have the pass and failed state, but we can also add more detail, and that can be done with annotations in Java. And we have the step annotation, parameter, and attachment. I already showed by accident the attachment result. That is basically the screenshot, and the step annotation will provide some text to your report. And if you like to run it with some extra information, we need to include aspect G for load time weaving. So it will weave the text into your report runtime. And if you like to do that, you have to add this to your test runner plugin. And this line is one of the most important lines. Huh? And we can try to, if you implement the page object model, for example, we can try to improve that a little bit to add those step annotations. And this is a normal of a simple method. It will navigate to sign in page. And that's also what the text says. And this one is a little bit more, not complex, but it can retrieve a argument, product name. So add product to cart with a product name. And the text is add product name, this is this value, to cart. So that's quite nice. And we can generate a trend line. And if you like to do that, we need to execute our test by Maven, Maven clean test. We need to generate a report, Maven Allure reporting, and then we need to copy the history files to our new target folder. And then we can create a report again, and then we see a trend line. And that is something I like to show you. And then we need to wrap it up, I guess. Index, yes. Let's open this. in Chrome. And here you see the trend line. This is two executions of the exact same thing. So it's quite straight, this line. But of course, you can see more movement if you execute a bigger test suite. And if you click here, 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 here you see all the text of those step annotations. This one contained, received one parameter. And you see the actual name in this case. And this received two, username, password, and here you can see the actual values. So that gives you quite nice information. And I think this is the last slide. All the code you've seen will be available on my GitHub account. This BrowserStack webinar 2021. And I made some listeners, and they are available on mavenrepository.com. And the demo websites we used is bstackdemo.com and my own demo website, seleniuminaction.com examples. And that contains some examples. So that was basically, the content of the webinar. So let's get back to you, Jay.
Fantastic. Thank you very much, Roy. Great session. We are running a bit over. So folks, please stay tuned for the questions. Yeah, we have some good questions lined up for you, Roy. So before we just quickly get into that, a few announcements, guys. We are going to be having another webinar in a month, our monthly webinar, Shift in Testing and Continuous Delivery with Kavita from eBay. She'll talk about eBay's journey into achieving their testing and delivery goals. So mark your calendars for that. The second announcement, please take a second to answer the yes or no to the live poll our team is running. This is if you'd like help, getting started with your test automation setup. We'd love to talk to you. Now let's dive into questions. For folks, we'll be sharing the links for the demo project, which Roy already has, but we'll be emailing those out.
Yeah.
Roy, we had a request if you can create a fail result in the demo, but if you have the time, that would be great. And
I think
we
I have a failed result. Oh, sorry, go ahead. Yeah.
We also have a few requests for how our community can get in touch with you for help with their automation. So if you could, ping your details in the chat, that'd be awesome.
I will do.
A bunch of questions on weights. So we talked about situations or scenarios where explicit weights are better. In what conditions would you recommend using implicit weights?
Actually, in none of the conditions, because you pretty much always end up with some troubles. Like if you like to check if some element does not exist, then it doesn't work that well. I always implement explicit weights. And other people also try to do that. And mostly what I've seen is they create helper classes. And maybe they are not so familiar with listeners. But the listener is, I think, one of the easiest implementations.
Next question. What's a good weight strategy for Android devices that may not include all the elements in the viewport?
Yeah, that's a good question. That's a little bit tricky indeed. I think we can come back to that in the email we will forward to the audience, right?
Sure, we could absolutely do that.
Yeah.
So there's a question, if we're using hard-coded or even dynamic timeouts, how do we deal with testing for elements that don't load quickly due to network throttling?
Yeah, that's a good question. The explicit wait will wait till the specific condition is met. And maybe it's the case that for some elements or some buttons or some actions, you need to increase the timeout. And that is something you can easily do with, for example, a static helper, because then you can supply the max timeout for every wait call.
Thanks, Roy. Question regarding the web driver event listener implementation has changed in Selenium 4.
Yeah.
Like to know how we can do this in Selenium 4.
Yeah, someone looked really closely, very good. Yes, this implementation was based on Selenium 3 because that's the latest stable version. In the code I will make available, I will also implement a Selenium 4 implementation, so that will be covered.
Awesome, making note of that. We have a question around resources or suggestions on how to use weights for mobile apps.
Yeah, with, for example, Appium, you can implement, not exactly the same, but a more dynamic weight mechanism. Of course, you can start with hard-coded weights and wait till some button appears or whatsoever, but you can also create your own polling weight condition. And a kind of polling weight condition, that's always the way I recommend people to implement.
Thanks, Roy.
And maybe we can give some example in the email we provide.
Sounds good. Regarding the wait strategy, how often do you want to wait for a web element to disappear, like a load or work icon? Are there any best practices you recommend?
Yeah, good question. Yeah, that's really dependent on the application you are testing. In one project, I had to test a pretty old application, and every action that you did in this application that resulted in some loader, some HTML loader in your screen. So you had to wait till this loader was gone, and then you could continue with the next action. If you was too quick, then it will result in some failure. So in that case, you need to check that some element does not exist. But of course, there are more cases, but it's not so common. That's true. Yeah.
Sure. Another question around a scenario, like let's say the app that I'm testing is unpredictable and can be fast or slow. An example given was Microsoft Teams that they're testing. What's the best type of wait for an app like this that might be unpredictable?
For unpredictable, I think implement something like a dynamic wait with a pretty high max timeout. If it finds the element earlier, then it will quit this loop, this dynamic wait. If it takes a little bit longer, then it will just wait a little bit longer. But if the app or the environment you are testing is always slow, if that's the common behavior of this environment, then you probably need to talk with someone and improve the environment.
Thanks, Roy. Follow-up question to that was, is there a way of writing weights for each step?
Yeah, you can implement this listener, and it will give you 15 ways of overriding the default functionality. And for those 15 methods, you can override the waiting mechanism for those 15 events.
Question
I'm not sure
regarding
if that really answers the question, but otherwise you need to rephrase.
Thanks, Roy. I will go through that question once again.
Yeah.
I'm just sure. Question regarding expected conditions class. Is it also available in JavaScript?
I don't think so, but you can implement your own kind of expected condition class. Actually, it depends on which framework you're using in JavaScript. But I always recommend, for example, in .NET, it's also no longer available, but you can implement your own expected conditions. In C#, it's no longer maintained. So I always try to implement my own version of that.
What issues could arise if there are dependent tests that run on different devices at the same time?
Sorry, can you repeat it?
Yeah, this is a question not regarding weights, but just in general. What issues do you think could arise if there are dependent tests running on different devices at the same time? And to elaborate, the entire package of tests on all devices, not only a single dependent test on one device.
Yeah, I get the question. I mentioned indeed that it's not a good practice to have dependent tests. If you have test dependencies, you should cover that within a test itself, because then you can run it in parallel. For example, if you mutate some data in one test case, then it will impact the other test case. So I always try to have independent test cases, and then they can run smoothly and independently in parallel.
Thanks, Roy. We have a few questions around fluent weights. Which is better, an explicit or fluent weight?
No, they're equally fine, I would say. With the fluent weight, you can easily suppress some exceptions, and there are some other sophisticated things you can do, but they are equally fine. Like the WebDriver weight and fluent weight, they are both fine.
Thanks for answering questions, folks. We are going to wrap up now because we're 5 minutes over. But Roy, I really appreciate you going through the questions. Folks, for questions that were not answered or support-related questions, we will be following up via email with the answers to your questions. If there's anything urgent, you can always reach out to our support. With that, Roy, thank you so much for coming on board. Learned a ton. I think I can say that for our community as well. That's a wrap. Thanks a ton, Roy.
Thanks for having me, and really good questions. Thank you.
Awesome. Everyone, before I let you go, we're running an NPS survey. Please, just add in your feedback for today's session. And for all of you that attended, thank you for tuning in, asking some great questions, and also, helping answer some of other people's questions. We hope to see you at our next monthly webinar, Shift in Testing and Continuous Delivery. With Kavita from eBay, I'm Jay Lave, your host, signing off for the day. Goodbye and take care. Thank you.